All right, we are going to do exponential growth today. And we're going to start off with compound interest again, only this time it's a different formula, because if you could imagine you put some money in a savings account and the interest is calculated every second of the day, 7 days a week, all year long, every year. Well, that's what this is for. This is called continuous compounding. And it's like it never stops. It just calculates interest, puts it in your account, calculates interest, put it in your account, calculates interest, put it in your account. So, yeah, here's the formula, the general formula for continuous compounding. Remember that before, when we did compound interest, we used this formula, A equals P times 1 plus R over N to the N T. Okay, that's for interest that's compounded annually, semi-annually, quarterly, monthly, daily. But this interest that we're working on today is compounded continuously. So here it is, APERT. That's the way people remember it, APERT. A-P-E-R-T. And what it is the accumulated interest equals the principal, the amount of money you put in the beginning, times E raised to the R T. But it looked like my T was too low. The T is up here with the exponent. So that's what we're going to be dealing with. And the first thing that we have to do is read the problem, okay? Suppose that $13,447 is invested at an interest rate of 6.5% per year, compounded continuously, which means we're going to use this formula, or a formula taken from that formula. This is called the general continuous compounding formula, and from it, we're going to put facts in that make it a specific continuous compounding formula that is specific to this problem. So, for instance, the principal is $13,447, and the interest rate is 6.5% interest, which is 6.5, but the decimal point is moved 2 places to the left. So your interest rate is going to be 0.065. And that's what the interest rate is going to be, written as a decimal. So we put the P part, that part, the initial amount of money goes in here, 13,447, and then times E, which is about 2.7, raised to the 0.065 T power. And that's going to be your specific growth function for your money. Okay, now we're going to use this formula to calculate how much money you'll have after 1 year, how much you'll have after 2 years, how much you'll have after 3 years, and, well, no, not 3 years, 5 years and 10 years. So this is what you do. We're going to put this in the calculator. A equals 13,447 times E, raised to the 0.065 times 1. Okay, and then for 2 years, it's going to be A equals 13,447 times E to the 0.065 times 2, because that's what T is. The T goes there. T is the number of years. Now for 5 years, we'll have A equals 13,447 times E to the 0.065 times 5. And for 10 years, A equals 13,447 times E to the 0.065 times 10. So we're just going to calculate these in the calculator and come out with an answer. And then after we've done that, we're going to find the doubling time. And this might be a new term for you, or it might not because you work in a bank. Doubling time is how long it takes the principal to equal 2 times itself. So we're going to find how long that $13,447 needs to be in the bank before the amount of money is 2 times $13,447. And you can use this in real life. Okay, notice that instead of A, they call this P of T. That's because writers of books call things anything they want, but it's still acting like the accumulated amount of money that you're going to have after a certain amount of time. So here I go. I'm going to say 13,447 times, and then I'm going to hit the second key and the LN key down here, and that gives me E raised to a power automatically. So that'll be 0.065 times 1. So that's all I have to do, and then hit enter. And that's what I'll get for 1 year. And then we've got to read the instructions about how much do you round and how many places do you carry it out. But for now, let's just go ahead and let T equal all of these numbers. And a really quick way to do this is to push the second key and the enter key. And that makes this reappear, and you can backspace and change the year. So that's what we'll get for 2 years. And then second enter, and I'll back up 2 places. That'll be for 5 years. And this will be, oh, I don't have to do that. Silly girl. There. Second enter, and I'll back up, and in place of a 5, I'll put a 10. And then hit enter. So these should be all of our amounts, and then we'll round them to the right, to the correct number of places. In fact, let's read it now. Round to 2 decimal places, 2 decimal places, 2 decimal places, 2 decimal places. Okay, we can do that. Okay, what the calculator says is 14,350.8 0.0874. And then for 2 years, 15313.82527. Yes. And then 18,611.0601 and 25,758.27753. Okay, now we have to round these. So we're told to round to 2 decimal places. That's the second decimal place. I look immediately to the right, and this 7 is going to cause the 8 to go up to a 9. So this answer will become 1435.0.09. And check it over here. Yes! Okay, now 15313.82. Here's the second decimal place. And this 5 is going to cause the 2 to round up to a 3. So our answer is going to be 15313.83. And then down here, we have $18,611.0601. Well, we're rounding to the second decimal place, and this 0 is not going to cause the 6 to round up to a 7. So this will be our answer. And yes, we've got them right so far. And now one more. 25758.27753. We're supposed to round to 2 decimal places. I look to the right. That 7 is going to cause this 7 to round up to an 8. So I'll have 25758.28. And I look over here, and that's right. So I am happy about that. Now, any discussion about that or questions?
No, you explained it perfectly.
Well, I don't know about that, but thank you. All right, now we have to find the doubling time. So since they're using this formula, P of T equals P e to the RT, which is P of T, because we don't know what T is, equals 13,447 e to the 0.065 T. We have to find T. How long will it take this amount over here to be 2 times this amount? Well, we're going to find out. I'm going to say 2 times 13,447 equals 13,447 e to the 0.065 T. And now we have to start going in steps. How do you solve an equation like this? So there are like 4 steps you go to. Step 1. You divide both sides of the equation by this number right here, by the P number. So we're going to have 2 times 1, 3, 447 equals 1,3,4,7 times e to the 0.065 t. And then I divide both sides of the equation by the number in front of the e. And they cancel out, which is the whole idea. But look what happens over here. The 13,447, 13,447 cancels out. And so what we're going to be left with is 2 equals e to the 0.065 t. Then I have to get that e down. And just like yesterday, you have to take the log of both sides. Day before yesterday, you have to take the log of both sides to get that t to come down to ground level. So, but there's an e in the equation, so I'm going to use ln. I'm going to take the ln of 2 equals the ln of e to the 0.065 t. This is step 2. Okay, so we're going to have the ln of 2, and that could be step 3. Let me think about it. I'm going to move the exponent down. That was the whole reason for taking the log of both sides. The ln of e is 1. 0.065t times 1 is 0.065t. So, yeah, this is step 3 right here, where you bring the exponent down. And step 4, you now have the ln of 2 equals 0.065 t. To solve for t, you divide both sides by 0.065, 0.065. So t is going to equal the ln of 2 divided by 0.065. And that is what I'm going to do right now. ln, I hit the ln key. The ln of 2 divided by 0.065. Enter. So there I have 10.6638028, and let's see how many places they want us to round to. Round to 1 decimal place. Okay, here's the 1 decimal place. I look to the right. That 6 is going to cause that 6 to round up to 7. So we're going to go with t equals 10.7 years. That's how long it's going to take for you to double your initial investment. Huh.
Whoa.
I know. I wanted to do something here. There. I wanted to copy that and put it on this sheet. Okay. Oh, super cool. I worried there wouldn't be enough room. But there is. There. Yeah. Okay. So what I should have done, wait a minute. What I should have done is, okay, so I'll put that down here too, because it'll help when you go back over the notes to actually see the calculations. And that is, after all, the reason to have notes. Yeah, all right, I like it. Okay. Now we have a problem that I bet you could be the person who would open up the account for these parents. Following the birth of a child, a parent wants to make an initial investment called P0. In other words, it's the principal. The principal and P0 are the same thing. The investment, P0, that will grow to $40,000 for the child's education at age 19. So we're given a lot of information here. P of T, or A, what I call A, the accumulated interest, is going to be 40,000, and 19 equals T. The interest is going to be compounded continuously at 5%, so that's R. Of course, we have to change 5% by moving the decimal point 2 places to the left. So it's going to be 0.05. All right, so let's get this started. Now they're calling the P, instead of just calling it P, they're calling it P0 now. Okay, fine. E to the RT. This is the general formula for all continuously compounded interest. Now what they're telling us is that the parents want to bring in, they want to invest some money so that it will grow to $40,000. Now R is 0.05, And we know that T is 19. So what we need to solve for is P naught. Okay, well, I need to find out, no I don't. This is going to be a number, e raised to the 0.05 times 19. This is the power that e is being raised to. So it's going to be a number. So I can divide both sides by that number. I don't know what it is yet, but I don't care. Don't tell anyone I said that. So e to the 0.05 times 19. Okay, cool. So I will be able to find out what P naught is just by doing this, and I didn't even have to change anything to logs. That's amazing. I thought this would be a lot harder than that. Darn, I might get paid less because I didn't make you work hard enough. That's a joke. 40,000 or 4,000? 40,000.
40,000.
Kid can't go to school on 4,000. Okay, 40,000 divided by second ln. That gives you e raised to a power. And so in the power place, I will hit 0.05 times 19. Okay, and enter. And so that's what we get. So let me copy this. Don't need it quite that big. Okay. Round to 2 decimal places. Well, this time that's going to be really, really easy because look at that. Here's your second decimal place, the 4. You look immediately to the right, and that 0 is not going to cause 60 to go up to 65. Not going to cause the 4 to go up to a 5. So we are done. 15,000. This is how much they need to put in the bank. 15,469. That's going to be their principal. They're going to have it invested for 19 years. And so when the child grows up, that will have become $40,000, which would be enough probably to put him or her through most of their college education.
Wow.
Yes, indeed. Well, I mean, if they don't want to go to Harvard or something. But you never know. Okay, any discussion about this? They give you all the information except for the principal, the initial investment.
Yes. Can you go ahead and show me again how you did the calculator thing?
Yes. I said 40,000, 40,000, 40,000 divided by E. Okay, and the way I got E raised to a number is I went second ln.
Okay, that's what I missed. Yep, that makes sense now. And then you just put the 0.05 times 19, and then that's how you get your answer.
Yes, hit enter and let's see. Let's make sure.
Second hit. Yep, that's what I got.
Okay, excellent. Okay, rich little kid. Not such a little kid. Now, this is important. I mean, this is important for your work. That this right here, A equals PE to the RT, that's the theoretical highest amount of money that can be earned for a particular principal and a particular interest rate and a particular amount of time. That's the theoretical highest limit, so that you can always tell which kind of savings account or CD or investment is going to be the best investment.
I will now be using this at work.
Yeah, you probably will be. Although probably the computer just does it for you. But you'll know what goes into it. Okay, we're going to talk about the population of a city and how populations grow. Populations grow exponentially, which means any kind of population, including bacterial growth, will start off real slow, grow really, really slowly. And then all of a sudden, look at how fast the human race has grown.
Oh, yeah.
So let me erase that. So populations, whether they're bunny rabbits or people or bacteria or I don't know about viruses, but I would suspect it's the same. They all grow exponentially if there's no natural enemy to bring them down. So, yes, here's George. George is here to say hi.
Hi,
But
George.
he wants to get on my desk, and I don't want him to get on my desk. Can you see him?
No. Yes, I can see him.
There's Georgie. Yes, your mother's crazy, okay? I admit it. Still crazy after all these years. Oh, I'm sorry. Okay, make yourself at home. It started to rain, incidentally. He's a little bit damp, but not real wet. All right, we have to find the exponential growth function. And guess what? It's the same as APERT, only they use different letters. That's for money. And for population growth, you have P of T, population after a time, equals the initial population times e to the kt, where k is called the growth constant, K is the growth constant. But you know what? K is just the same as R. It's a rate of growth. R is the rate of growth of your money. K is the rate of growth of populations. Actually, K shows up a lot. Growth constant. Okay, so, see, let's put a little arrow. They're the same. If you forgot this, you could always use the money one. All right, now, we have to find the exponential growth function for this problem. Okay, so this study starts in 2012. We would call that T0 or T0. T0 means the very beginning, and you as the researcher, for instance, would have said in 2012, I think I'm going to begin a study of population. Okay, so for your study, that's the beginning of time. And at that time, the population, P0, was 5.09 million. Now, it tells us what the exponential growth rate is, and that's 3.93%. But to change that to a decimal, we move the decimal point 2 places to the left and fill in that empty dip with a 0. So the growth constant K is 0.0393. All you have to do is put that information in here so that we'll have P of T equals 5.09, and we know that stands for millions, times e to the 0.0393 t. And so that's what they give us there. 5.09, because when you started your study, that was the population. And you calculated that the growth rate was 0.0393 t, 0.0393. And then that's going to be multiplied by however many years you're talking about. So that's just a method for, the way that you find the specific growth formula is by just filling in the information into the general formula. So 5.09 goes there, and 0.0393 goes there. And that's what they did. Now, we want to know well, I don't want to know, but they want to know, what is the population in 2018? Well, the beginning is 2012. So that means what T is going to equal is going to be 2018 minus 2012. So that's going to be 6, right? Yes.
Yes.
Say yes, please.
Yes.
So here's what we're going to do. We're going to take this formula, 5.09 e to the 0.0393, and in the t's place, we're going to put a 6. So we're going to get to drag out the calculator again. Clear this, and I need to make this smaller so I can see what the numbers are. 5.09 e to the 0.0393 times 6. So, yes, I need to move that up. 5.09 second ln 0.0393 times 6. And so that's what I got. And let's see, enter. And I'm going to do this. This is the quickest, easiest way to bring these numbers over. So what is this? This is B. And let's see, it says round to 1 decimal place. That's right here. Uh-oh, not yet. Okay, 1 decimal place. And this 4 will not cause that 4 to go up to a 5. So our answer for B is going to be 6.4 million. And if the model is valid and true, then the population will have been close to 6.4 million, one way or another, in 2018. All right, now we have a trickier problem. C says the population of the city will be 7 million in about how many years after 2012? Okay. Well, aside from seeing the answer, we have to pretend we can't see it. All right, here's our formula. P of T, P at that year, equals 5.09 e to the 0.0393 t. We're going to use this formula, and now they're saying, okay, well, when's it going to be 7 million? So I put a 7 equals 5.09 e to the 0.0393 t. Now here's where we do that 3 or 4 step problem again. Step 1. Divide both sides of this equation by the P0 number, the number in front of E. Okay, over here it cancels out. And do not put that in the calculator yet. That's a very important deal. Okay, now step 2. We've got 7 over 5.09 equals, I don't need that much room, equals E, I do need the room there, 0.0393 t. And because t is up in the air and I need it to come down so I can say t equals, I have to take the ln of both sides. Okay. Now, step 3, we're going to bring down our exponent, which is the whole reason for doing this. Step 3. The ln of 7 over 5.09, don't do anything about it yet. I mean, don't put it in the calculator yet, equals 0.0393 t times the ln of E. And the ln of E is 1. So this is just 0.0393 t times 1. And then step 4, you don't use your calculator until the very last step. going to have the ln of 7 over 5.09 equals 0.0393 t, and to solve for t, I divide both sides by 0.0393, 0.0393. And now I get my trusty calculator and move it over so I can see what the numbers are. There. I'm going to take the ln of 7 divided by 5.09, parentheses closed, divided by 0.0393. Then hit enter. So that's the ln of 7 divided by 5.09, close the parentheses, divided by 0.0393. And that's what I get. So I'm going to move that answer over to the notes. So I'll make this look real fancy and put an equal sign. T equals, looks like I always knew it.
Boom.
And here's now, what do they say? I mean, I really should have always look first and see how many decimal places you're supposed to round to. I didn't. Okay, round to 1 decimal place. Got it. Whoop. Whoop. Okay. So that's going to be 8.1, easy to see because 0 is definitely not going to cause the 1 to round up. So that's our answer for part C. This is very, very important, very, very important. I'll even write it. Very, very important. Do not use a calculator or your calculator or anybody's calculator until the last step. Otherwise, you'll get round-off error. Here. One more problem. There are people who collect coins, and rare coins are, worth a lot of money. It says a coin sold for $274 in 1979 and was sold again in 1986 for $484. Assume that the growth in value V of the collector's item was exponential. And look at this, they're referring to things as V's instead of like APERT. Okay, so we can play that game. We can say, okay, our general formula is going to be V of t equals V naught times e to the k t. Initial value, initial being when you started looking at this situation. So 1979 would be T naught, when time began for this particular problem. And V naught is going to be 274. Okay, so then our specific, almost specific formula is going to be 274 e to the kt. But we don't have k, and we can't do the problem if we don't have k. So we have to find k. And that's why they gave us this later date and amount, so that we can find k. So we can find k. And here's how we're going to find it. Yeah, look, they say round to the nearest thousandth. Thousandth is 3 decimal places. Okay, so here we go. This is what I know so far. Is this A? I think it's A. This is what I know so far. V at some later t equals 274 e to the kt. Okay. We have this other miscellaneous fact, and it is that in 1986, the coin sold for $4.84. So 1986, and $484. Well, 1986, that is T equals 1986 minus 1979. Okay, because time began for us at 1979. So from 1979 to 1986, time has progressed 7 years. So we can now do this. The later value, 484, equals 274. E to the k, we don't know what that is, but we do know that the number of years is 7. And a better way to write this, probably, is 484 equals 274 e to the 7k. And we're trying to find k. K is acting like x right now. We need to solve for k. However, before I take the ln of both sides, I have to do step 1. Which is to divide both sides of the equation by the number in front of E. And don't put it in your calculator. When I was a student, I had to like fight the urge to use my calculator. Well, I didn't have a calculator. There weren't any calculators then. But to try to, there must have been calculators. Well, no, there weren't.
What?
All numbers that are in our calculators used to be in big, gigantic books. And so all the math books would, in the back, they were especially big and heavy because in the back you contain they contained pages of K's, you know, and the numbers, the ln. Like when I take the ln of 484 over 274, well, I'll show you. Anyway, you would find it in a book or in the back of your math book. Everybody had to bring their math book every day.
Wow.
Life is so much easier. Calculators are so much lighter. Anyway, yes, back to work. Back to work. Step 2. So we're going to take the ln of both sides. Okay. Now, the whole reason that we did that is to bring this down. So we're going to have the ln of 484 over 274 equals 7k times the ln of E, which is, what is the ln of E?
1.
1! So this is 7k times the ln of E. The ln of E is 1, so 7k times 1 is just 7k. So, step 3. I think I'm losing my steps. I don't know. Step 3. That's why I say 3 or 4 steps. We're going to have the ln of 484 over 274 equals 7k. No, this was step 3. Okay. This is step 4. Okay. Divide both sides by 7, and then we'll get what k is. So k equals the ln of 484 divided by 274. You interested in how we did this? You have to unpack this using the arithmetic of logarithms. Ln 484 minus, that's the quotient rule, the ln of 274. So we would have to look up the ln of 484 and the ln of 274 and do that subtraction and then divide by 7.
Ah, so that's how you did it back in the day.
Back in the day. Give me this day anytime. Not COVID-19, but, you know, other things about today, like calculators. Definitely. All right, so K then is going to equal 44 over 2, the ln of 44 over 274 divided by 7. And we are going to get our trusty calculator out. And take the ln of 484 divided by 274, close parentheses, divided by 7. And copy that, take it back to the notes. What have I done? Oh, goodness. All right. I thought I'd really blown it. Okay. There. 0.081, round to the nearest thousandth. 3 decimal places. 1, 2, 3. I look over here at the 2, and the 2 is not big enough to round the 1 up to a 2. So we're going to stay at 0.081. And that's the answer to part A. Sure, I'm glad this is the last problem. Yes, yes it is. All right, let's look at B, part B. Find the exponential growth function. So all you have to do is put your K in to the function. So part B is just going to be V of T equals 274 e to the 0.081 t. You just put in your K. You had the other numbers. Well, that one. And I should move the decimal point up closer to the 0, because there are going to be people looking at the notes who probably weren't here. So they need to know what's going on. C. All right. C. Estimate the value of the coin in 2007. My goodness. Okay, well, we have to figure out what T is going to be. Well, let's write this. V of T equals 274 e to the 0.081 t, and T is going to be 2007 minus 1979. Okay, I suggest we get the calculator. 2007 minus 1979. Enter. 28 years. So how much is that little coin going to be worth in 28 years? Well,
That's
I mean,
insane.
pardon me?
Yeah. Like to be insane.
All right, so V of 28. That is the value in 28 years is going to be 274 e to the 0.081 times 28. If the model is correct or relatively correct. Okay, so 274 second ln 0.081 times 28. Let's make it big. So that's what I put in the calculator right there. And the answer I get is that. Okay, so yeah. Now what does it say? It says round to the nearest whole dollar. Okay, so here's where the dollar part ends, the whole number part. Oh. There. The whole number part ends with the 6. So I look over at the 8, and the 8 is big enough to make the 6 round up to a 7. So our answer is going to be 2647. And that's all you have to put. Right there. 2 more parts to go, D and E. What is the doubling time? Okay, doubling time. That is when does $274 become 2 times $274? Oh no, let's find out. Here's our formula. Oh, and we're in D now. Here's our formula, V of t, the value at some other time, equals the original value, 274, times E to the, oh, I forget what that is, 0.081. 0.081 t. Well, that value at a later time is going to be 2 times 274. Okay, equals 274 e to the 0.081 t. Now, step 1. Divide both sides by the number in front of E, which is 274. Cancels out here, but also cancels out here, leaving me with 2 equals e to the 0.081 t. So step 2 is where you take the ln of both sides. Both sides of the equation. Like that. And step 3 ln 2 equals 0.081 t times the ln of e, which is
1.
yes! So step 4. ln 2 equals 0.081 t. I divide both sides by 0.081 in order to solve for t. And I'm going to find that number right now. So ln 2 divided by, no, I have to close my parentheses, divided by 0.081. So I get that number. And let's see if we agree with them. Hope I do. D, 8.6. Round to the nearest tenth. The nearest tenth is 1 decimal point. So we're going to round here. I look over at the 5. The 5 is just barely big enough to round this 5 up to a 6. So 8.6. And then finally, E. Step E. Find the amount of time after which the value of the coin will be $2,882. Okay, so 2882. V of t equals 274 times e to the 0.081 t. And how many years is it going to take for the value after time, v of t, to be 2882? Okay, so step 1. Divide both sides by the number in front of e. But don't put it in your calculator yet. Okay, 2882 over 274. No. This is step 2. Equals e to the 0.081 t. And I take the ln of both sides. Barbara, do it the right way. Okay. Be neater. ln. Now, step 3. The ln of 2882 over 274 equals 0.081 t times the ln of e, and I'm not going to ask what it equals this time because you clearly know. And then step
1.
Very good. And then step 4, we're going to divide all this stuff by 0.081. So the ln of 2882 over 274 equals 0.081 t over 0.081 over 0.081. And so t is going to equal no. There. The ln of 2882 divided by 274, close parentheses, divided by 0.081. So I get 29.05076136. So 29 years? Don't know.
Yeah, I believe so.
29.1 because they want it rounded.
Oh, okay.
So to one decimal place right there, and that 5 to the right is going to cause the 0 to go up to a 1. So 29.1 years.
Woo!
And we have discovered and dealt with some mysteries of the universe today.